Hey, Happy New Year, everybody. It's another
Hold on, Chris.
showing live.
Yeah, I know. Here we go.
So,
You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
Go, Chris.
hey, Happy New Year, everybody. It's another episode of All Things 3D. Today we've got an exciting first of the year program. We've got a special guest joining us live. His name is William, and he's from Body Labs. Welcome to the show, William.
Thanks very much. Glad to be here, Chris.
And you like to be called Bill, so Bill.
Will work.
Okay, Bill it is. So, Bill, why don't you tell us a little bit about yourself, who you are and where you're from and what you do.
Great. Cool. Well, my name's Bill O'Farrell. I'm one of the co-founders and the CEO of a company called Body Labs. Body Labs is a startup. We were spun off out of principally Brown University, and we've licensed technology from Brown as well as technology from the Max Planck Institute, which is where the original research has been continuing.
No way!
Yeah.
With Nassim Haramein?
No, it's actually a guy named Michael Black, who is a professor at Brown. And Michael took his group over. He's now director of the Perceiving Systems Group at Brown at the Max Planck Institute.
Oh, wow.
Yeah. So we've got an exclusive license to all the 3D body modeling from those guys. And we're basically doing, I'm sure we'll talk in depth about it, is trying to provide the human body as a digital platform for sort of creating, designing, manufacturing, buying, and selling goods and services. We're based in New York. We're a dozen people.
Wow.
There's a lot of people in New York doing these kind of things. We just had a couple of people on earlier, 2 or 3 months ago, that are doing something very similar. No, actually, they're not doing something similar to this, but they're doing body scan. So if you notice, I've got the website up, your first or your initial page, so I thought I'd just go right into it. What is Body Labs? I mean, you see a little animated character there, so maybe you can give us kind of an overview of what Body Labs is before we get into some more specific questions.
Absolutely. So we basically have licensed and are now commercializing a very sophisticated, we think the most sophisticated system in the world. It's a statistical model of the human body. So it encompasses the full breadth of human shape, the full breadth of human pose. And what that means is that we can take from either scan data or measurement data information, and as you guys probably know, a scan, for example, is just a point cloud. And we can convert that into a 3D model, which the computer can actually understand as a human body, and we can run it through a full range of human motion with full fidelity to the way humans really move in real life. And from that perspective, we feel like we are now, for the first time ever, enabling any specific human being or any prototypical human being to actually be understood by the computer in a way that previously we've only been able to use proxies for, like measurements or weight or size charts or mannequins. So now you can really design specifically around a particular or prototypical body. Did that just floor you guys?
Yeah, actually, why don't you go back a sentence? You broke up a little bit on my end. One of the things that I've noticed, if you try not to move, just move your mouth, that sometimes eliminates the audio portion. I know that's hard to do, but that way we don't have to lose the video.
Okay. Yeah, I find when I move my mouth, usually bad things happen, but I'll keep trying. Yeah, go ahead.
So jump back just a little bit, and then mention it again.
So with the statistical model, which is built on thousands and thousands and thousands of scans of thousands of different people in thousands of different shapes and thousands of different poses, we're able to recreate any specific human being or any prototypical human being as a 3D avatar and run that person through a full range of human motion and have them perform exactly as they would in real life. And so now, traditionally, if you think about it, from time immemorial, we've only really been able to identify and describe the human body as through proxies, through measurements, through mannequins, size charts, things like that. Now we can actually take that information and enable a computer to understand any particular or prototypical human being as a body and as a platform for designing all kinds of goods and services.
It sounds good. Right now I'm on. Let me jump back to myself. Actually, I think I am on myself. If you noticed here, I'm looking at your website, and you build this upon a statistical data. I thought I read somewhere that you use something from the U.S. Army. Is that correct? I assume that would be a good place to start because they have obviously taking many statistical measurements on a lot of the troops that have gone through. So is this true, or?
So that's part of our database, and part of the research we've licensed was funded by the U.S. Army. The guys up in Natick who, anthropometrists and really actually quite good at what they do. Basically, the Army has given us, I think most recently they've given us about 12,000 high-quality scans of male and female soldiers. And that's part of the information we use to build our statistical model around. But that's not the only source that we've got information from a variety of public data sources as well as a bunch of scans that have been taken both at universities and through our own company.
So
and from that we have.
I'm sorry. How does the statistical data help you? I mean, I've done some body scanning and I've also done some rigging. But one of the things that you mentioned in what you're working with is you're using the statistical data to provide realistic movement, realistic measurements, or at least for comparison. So maybe you could give us a little bit more information in that area.
So if you've worked in scanning, and this is for us sort of an interesting, in fact, an interesting marketing challenge because scanners are great. We love scanners. We want everyone in the world to have a scanner. But the information that comes off a scanner is just a point cloud. It's just a static set of data points. And while you can do some things with that, for example, you can run that through a software system and possibly take measurements out. It really, the computer doesn't understand it as anything other than a point cloud. What we do is we use our statistical model and we align that point cloud with the statistical model, and we basically say, look, there's a body here. That point cloud represents a body. Now let's apply everything we know about the breadth of human shape and the breadth of human pose, and let's change that body, if you will, transform that body into a 3D avatar. And with that, we can imbue it with all of the knowledge that we have about how the human body moves and how it poses, and enable that to then be dropped into a variety of applications like CAD programs or fitness applications, compare bodies for apparel, things like that. Does that answer your question, Nick?
Yeah, pretty much. So essentially, if I sent you, as you call it, a point cloud, normally I deal with meshes that are actually faces. If I sent you, let's say, an STL and OBJ file, you'll be able to work with that?
Yeah, typically. We have a web service called Body Hub where people can upload scans. And now the processing happens in the cloud. It's not real time yet, but within sort of minutes to maybe half an hour, we create the body model. And then that can be downloaded from our bodyhub.com service.
So let me get this straight. Let me get this straight. You can take a scan of somebody that's not animated, and you can animate it.
That's right. Yeah, that's right. And the reason we can animate it. So the other thing we can do, which I think there should be some examples of that on the website, is we can take the marker data from motion capture data, and we can apply that literally to any body. And the reason we can do that is because the statistical model enables us to keep all of the bodies in complete point-to-point correspondence. So if you take a motion capture file that's been captured with one particular body, we can take that marker data and then we can apply it on the exact same points as originally captured to any other avatar that we've created. So we can animate that either with motion capture data, or we could animate it through, it can be rigged. So our ability to understand the breadth of human motion is part of the technology we've licensed.
Wow.
So I'm playing the video right now from your YouTube. So can you see that, Bill?
Yep. Yeah, so this is one of the applications that people are. This is probably actually the lowest hanging fruit right now in our pardon me, in our business applications, because apparel. If you think about it, sort of buildings and products are all designed using CAD programs. The apparel market actually isn't quite as sophisticated yet, but it's changing. So rather than actually calling it a live fit model, dressing, well, first you have to design a piece of apparel, and then you have to sort of cut a pattern, and then you have to actually sew a pattern, and then you have to drape it on a fit model. You can now do a substantial portion of that virtually, and you can do sort of all the sampling virtually, because we're, for the first time ever, capable of dropping that fit model exactly as he or she looks in real life into the CAD program.
Unbelievable.
Yeah, pretty
it's
cool.
cool.
Well, as mentioned in one of your services, you use a Kinect 2. So if I have a
Right.
Kinect 2, I could use that with Body Hub and scan myself. And
Yeah.
if I had created, go ahead. I'm sorry.
Well, so there's a little applet we have called Body Snap. So that's for free. You can download that for free. You need obviously a Windows PC or Surface with I think the what's it called, Kinect for Windows software. But exactly that. You just use the Kinect 2 and upload to Body Hub.
Okay, so you just download their APK and then load it into your machine, and then use your little applet, and you'll be able to upload that. Correct?
That's exactly right. Yeah. And
Chris, next time you come over, we've got to try that.
yeah, I wish you guys.
Let me
running.
ask you a question. If, let's say, and I mentioned this one of my questions here, I have a structure sensor, and I've worked out some products for that as well. Can you take, let's say if I make a scan of my body in structure sensor, and I alluded to this earlier, can I upload the, let's say, an STL and OBJ file and do the same thing as if I had a Kinect 2?
Yeah,
Are
the
you
short
using
answer
other
is
scan?
yeah, no, the short answer is yes. Our objective is to be completely scanner agnostic. Again, if it's a point cloud, we just want to be able to take that and convert it into a body. The reality is right now, I mean, the good news actually is that if you think about it, sort of, there's the Kinect, there's Google's got a Project Tango coming out, Apple bought PrimeSense, Intel is doing all kinds of stuff. So, we anticipate that these sort of 3D sensors, these scanning technologies, are going to be on all kinds of devices, consumer devices, laptops, etc. So the short answer is yes, we should be able to take that scan and convert it into a body model. Now, with sort of lower end scanners, there may be some upfront processing we'll want to do to improve the quality, and that's one of the things we've done with the Kinect. The Kinect's an amazing device, but it's still a fairly low end consumer device. So we sort of pay special attention to a variety of information that comes from that, and we may or may not have to do that with other scanners depending on which one it is.
Yeah, I know we actually did an interview with Artec, and they're coming out with body scanner booths, as they call them, somewhat pricey, 80,000 plus, but supposedly they have one in San Jose, and I didn't get a chance to go this time. Maybe when I go back up to San Francisco, or they may actually be at the Autodesk scanning conference. Are you going to that as well? I think it's towards the end of February.
Certainly try to get there. Absolutely.
Okay.
Yeah.
Well, hopefully, if I don't see you at CDS, I hope I see you there.
Yeah, we should make a plan to get together. That'd be fun.
So let's get into the two areas that you identify as your applications, and we'll start with the gaming. What do you see or explore that this being used for? I remember Second Life, but it kind of died out a little bit. Or do you see a resurgence now with the Oculus Rift, that VR and the Second Life or these second VR worlds are going to be making a comeback? And do you see a potential there of taking the scans and providing these avatars or gaming characters, Bill?
Yeah, that's a good question. So, we with a lot of the businesses we see, we feel like the fundamental building block for so many different things is the human body. So, in particular with gaming, first there's sort of maybe two sides of that. There's the game design. So a lot of our tools can be used to quickly create characters, to animate them, to rig them, to interchange them more quickly. So there's sort of tools for the game designers, but then for the game players, we anticipate that not in the very near future, folks will be scanning themselves, with their Kinect or, in front of their television and dropping themselves into video games and making, sort of deforming themselves in all kinds of funky ways. So we see both the design element as well as the gameplay element as sort of potential applications for us. And I'd also add that when it comes to the virtual reality world, you need to sort of be able to visualize yourself and others in that world, just so you can stay oriented. And we feel like that's a real sort of slightly longer term opportunity for us, because right now we're not real time, but we certainly can do a lot to change that. So we see all kinds of opportunities in those areas.
I see. The one that I always kind of fantasize about is scanning yourself and then going to like Amazon's website and trying on clothes or shoes, in a virtual world. So like and you could like look at yourself in the clothes, kind of like what you're showing here in the apparel world. You're actually doing what I've been like. I know this is coming. We all know this is coming. And so I've seen it, and then click an order, and 2 days later, the Amazon Prime brings you your pair of shoes. And I've seen. I also think like the Oculus Rift, you'll walk around and you'll meet your virtual friends at the mall, and what do you think about this dress? Do you think it's cute? Or it's like that's coming. Whether we like it or not, that's all coming, because people don't want to go to the store. They want to stay home.
Bill, back to your scanning and as far as gaming, I'm actually familiar with Mixamo, or however it's pronounced, Mixamo. Mixamo.
Yep.
Somebody else, one of my clients, is wanting to do something similar using the structure sensor. So I'm familiar with this, and so from what I understand, you'll be able to take the scanned objects from Body Labs and then bring them into Mixamo, which, if I remember correctly, charges, I think, $50 per scan. Is that correct? Will this be included in the price on your end, or how does that work?
Yeah, so as you probably know, Mixamo is sort of a character creation environment. I think it works with the Unity platform as well as others, or Steam. And right now the Kinect scans that we're doing, we're still in beta. Those are all free. And certainly, when we sort of launch the application as when it goes live, if you will, there'll be some sort of freemium service. So we'll enable some level of initial scans, and then over a certain number there'll be a charge. But initially there'll be no charge for a single character or some small number of characters.
Well, obviously it's going to be pretty cool, and like Chris alluded to, yeah, we'll have these new Amazon VR worlds that we go in. No more of the mall, but we go into the Amazon mall. Amazon is going to take our blood next, and then they're going to know exactly what drugs we need. Yeah, it's going to be scary. So it's exciting.
Whoa! Look at this demo. For the listeners out there, you really got to head over to bodylabs.com and check out some of these demos that they've got going on. Where can we do this demo that we're watching, this avatar? This guy just fully animated himself doing a gangster sea walk down the street.
Right. So that was done in the Mix. So that was our body done in the Mixamo platform. We sort of, our bodies come in and we inherit, if you will, we imbue it with the Mixamo riggings, and then all of the animation capabilities that are in the Mixamo environment just transfer automatically. So, and we anticipate doing that for all kinds of different video gaming engines.
Well, who doesn't want to play a video game as themselves?
Well, I'd like to play a video game as myself as Superman, but
Yeah, but it's like, who doesn't want to play as themselves? This is like super cool.
Yeah, Chris, there was a game, I think it was called Rainbow Six, if I remember correctly, that had built in a rudimentary scanning process where you take a frontal view of your face and then a side view, and then it combines them together to create a crude representation of your face, but it's pretty scary, especially in a
Tony Hawk
game.
And FIFA, those games do that too. Yeah, there's a few games but this is like taking it to the whole. This is like your actual data is in the game. It's not like you're trying to recreate you and it kind of looks like you. This
Well,
is
let
like,
me lose 10 pounds first before I do that.
hey, you know, it could be inspiring you to do that. That's
Yeah,
it's the
actually,
auxiliary benefit of it.
yeah, we're going to be doing.
Almost every model we make, every scan we turn into a model. The people, someone does the exact same thing. Gee, I just ate big Indian food lunch. I really should do this next week or something. It's hysterical.
Yeah. And that's interesting. On 3D Review on Friday, when I was up in San Francisco, I did an item on VFit. So I guess there's somebody else that is creating a scanning booth so that they would scan you for the gym. So that way, and I said, I don't know if I want to go to a gym and get this exact body model. You know, it's bad enough I look in the mirror, but the next thing you know, I'm now looking at this 3D representation of myself.
You know, that's interesting because we have a lot of developers who are sort of looking at that area, and that's something that our technology is, you know, very sort of suited for. And again, it goes to this point-to-point correspondence because you can scan and then change your body into a model like day one in your fitness regime, and then we can compare you week to week to week, and we can actually show how your body shape changes, your geometry changes. You know, right now you get weight and you get, you know, somebody sort of using calipers to tell your BMI, but really when you're working out, what you really care about is your body shape. So we're able to sort of track the body shape changes. We do that for pregnancy. We can sort of track how we can predict how a woman's body will change over pregnancy. So there's a whole bunch of sort of what the engineers call longitudinal data we can do. I call it temporal, but you know, sort of see how a body changes over time with a regime, with pregnancy, with age. So there's a lot of really important kind of health and fitness applications as well.
Yeah, that's really cool. Well, let's get back into one more item that you show as an application, and that's Apparel. And it shows here body model number 1, body model number 2, and then a comparison of these, and then it looks like you have almost like an infrared data set there that shows of different colors. I guess these are deviations. Maybe you can expound upon that a little bit. Do you see that, Bill?
Yeah, I do, and this is, you know, this comparative capability is important. You know, you're talking about the Amazon application. For us, we absolutely envision that world, and what we don't, you know, I think virtual try-on, sort of taking your avatar and trying clothes on, you know, that we think that's interesting. There's some retailers who feel like, you know, that might not be the best way to sell clothes because you'd rather see a model in the clothes than yourself a lot of times. But what's important is sort of fit. And the way we deal with that is we say, well, look, you know, we've got your avatar, and we can get the avatar either by scanning and creating an avatar out of a fit model, or by just taking the sizing rules. And we can compare your body to the body of the person for whom that clothing was actually designed. So that way we can say, well, you know, if you're a woman, you're maybe, I don't know, 98% the exact same size as the size 6 Nike Fit model, but you're only sort of 85% the exact same shape as, say, the Lululemon Fit model. And then we would do a heat map or some other. We could show you, you know, how your body varies and changes or is different than that particular fit model. And that would enable you to actually shop much more accurately.
Sure.
And we would never, we would never actually say that fits you or doesn't. What we'd say is, that clothing is designed for someone who's got 98% your exact body shape, so the manufacturer thinks that's your shape.
Yeah, the manufacturer thinks that Levi's will fit you better than Wranglers.
Exactly.
Well, that's what they say often. So essentially, instead of saying, as Chris identified, showing you in the clothing, you'd identify, well, you would fit this approximately or specifically this statistical amount. And then from there, they can gauge if that would be a good fit or not, instead of saying, you'd look horrendous in this.
Well, it could essentially eliminate, I mean, it could eliminate a lot of, I mean, trying on clothes is such a pain in the butt. And this could just eliminate a lot of the, you know, and like fitting, like having to get things tailored, like, you know, short guys like me, you know, I'm like 5'9" or 5'8", and it's like it's a pain in the butt to try to find pants sometimes, because a lot of times they're too long, and this would just totally eliminate it.
Yeah, and we also see, you know, we see that sort of comparative capability with the fit model and the brands and things. But also, if you can imagine, you know, just say everybody with a Facebook page also had their 3D body model as part of their digital online ID, as part of their Facebook account, then you could say, well, look, there's 10,000 people out there with 99% the exact same body shape as you. So what did they buy, and what did they need to get it shortened? Did they, how do they wear it? And you could actually imagine this incredibly powerful set of recommendation engines and subgroups, subpopulations of shaped, geometrically shaped, similarly shaped people coming together to share all kinds of information.
Well, and it would be easier for the you could publish statistical models. You could actually publish this data for the manufacturers, for them to make subcategories of products that so that they can more directly target groups of people more accurately. It's almost like a fit model, but instead of having one person, you've got 10,000.
And that's exactly right. We're already doing that, and that's most of our customers right now are from the apparel space. But we'll do that for example, athletes. Sort of NFL football, NFL running backs or swimmers, or they have bodies that are much different than the standard kind of average American body. So we'll take those subpopulations and we'll use what we understand about the body, but only train on the data that come from that particular subpopulation. So and that enables those manufacturers to design specifically for those sports.
Wow.
Yeah,
What
it
a
looks
cool
exciting. So I
project.
notice here, and this also seems pretty interesting. Not only can you conform to clothing, but you can animate it to actually show the variance in the clothing material. So you'll know what I'm assuming the tight spots will be before you actually have to put it on. Is that correct, Bill?
Yeah, I do want to just be clear about it. We provide the bodies. Now the clothing demos you're seeing, there are probably about half a dozen computer-aided design programs that do garment simulation, that sort of encompass the physics of the garments. Like Browseware has vStitcher and Clo3D and Electra and some of these other guys. So what we do is we provide highly accurate animated bodies, and then they drape the clothing in those CAD programs according to the physics that they've sort of accommodated in their software, which is a very difficult problem. Sort of the physics of the human body, the shape and pose of the human body is very complicated. The physics of garments or of textiles and apparel is also incredibly complicated.
Yeah. I grew up in a screen printing shop for the 30 years I've been alive, and one of the things that's really hard is when you're going to sell. Like, this is I see another opportunity too for sales, because when you're showing especially women's garments, when you show them on a hanger,
Right.
they look terrible, but on a model they look great. So it's really hard to sell things on a hanger, when you're going to sell a client some new style or something. They'll look at it and be like, what, that's weird looking, because it doesn't look right, because it's not draped over a human body. So then that's when you have to get dress forms, or you have to get a model, or fit
Exactly.
models or whatever.
People are already 3D printing some of these models. Maybe just the torso, or 3D printing body parts. The thighs, to put sort of pads on the thighs or things like that. So we see sort of really kind of minimizing the cost of all of these sort of retail accessories, if you will.
Wow,
Yeah,
very cool.
that's pretty cool. So why don't you summarize, Bill, what does a person need to do in order to get involved with Body Labs? What type of equipment, what type of applications to get something up to you so that you can simulate their body type, send them a model back, and then what are some of the services? If you could do that really quick in about 30 seconds, we'd appreciate it, and then we'll kind of summarize and recap everything again.
Well, if if you're a consumer and you want your body model, then using the Kinect is the best. The Kinect 2 and Body Snap is the best way to do it. So just go to Body Hub, download Body Snap, and upload your scan. Business to business, that's where a lot of our current business is, with the apparel manufacturers, the Army, other folks like that. So that really is much more of a design services, fit services, and population sizing set of services we provide, and that's really tends to be for the bigger apparel designers and equipment designers.
So again,
good
it's
enough?
the Kinect and the Kinect 2 now. If I remember correctly, originally it was just the Kinect. Is it to
No,
connect
the
to as
Kinect
well?
visual aid is what Body Snap is designed for. But by the way, any scan, just upload any scan, but be in tight fitting or gym clothes, and we'll see if we can fit it. Certainly, anything more powerful than a Kinect scanner, we'll be able to fit. Laser scanner, things like that.
Okay, well that sounds good. And then, how long does it take before you get a model back?
I'm going to say around 30 minutes. Sometimes a little sooner, sometimes a little later. It should be automated. When we see a scan from a machine we haven't seen before, we tend to hand check it. But it's about a half an hour, and that'll get faster.
And your models aren't rigged, so you'd have to go to Mixamo or something like that to rig the models, correct?
Currently, that's right. Although we are now trying to accommodate as broad a spectrum of third-party software as we can, and we will have a body kit. Our API is coming out in the beginning of next month, so developers will be able to do a lot of this themselves.
Okay, and what language is the API in?
Oh, that's a good question. I don't know the answer to that. I'm just the CEO.
Okay. Well, maybe you could email me that, and I'll put it in the show
I would
notes.
definitely like to know that. That's embarrassing. Yeah.
Is it a Windows platform?
No. It'll be a web-based API.
Okay. All right. So probably C# or maybe even JavaScript or something like that.
I would presume the latter.
Okay. Okay. Well, that's about it for me. Chris, do you have anything for Bill before we?
Yeah,
end
I
it?
just really enjoyed talking with you and finding out about Body Labs. I hope everybody learned as much as I did, and definitely would love to follow up with you. After you launch this, when are you planning on? It says early 2015. So do you have a ballpark? Like, is that
The
January?
API.
Yeah.
Yeah. Well, it'll be iterative, but we should have some pretty good functionality out there. Middle of next month, and then we'll just be adding tons and tons of stuff over the year.
Awesome. Well, thanks so much for coming on the program, and for the listeners again that want to go check it out, it's bodylabs.com, and they've got some really awesome animations up there. You got to go check them out. So.
That's great.
You said and Bill, you said you will be at CES. You just won't have a booth. So if somebody wanted to contact you there, do you have a location, or just send you an email and maybe hook up?
It's really easy. Bill@bodylabs.com.
Bill@bodylabs.com. Awesome.
Okay.
Cool.
Well, great. I appreciate it, and I hope to see you on Thursday. And Chris?
Yeah, I do too.
Yep.
Thanks, Chris. Thanks, Mike.
And we'll be joining you live from CES. Not me. I will be hosting the Google Hangout here at the Stronghold, and but Mike will be on the street this time. We'll swap roles. Last year I was at the Maker Faire, and he was in the studio. But this year we'll be.
Let's hope it works, because I've heard that the network is pretty congested. So worst case is. I'll wait till get in the hotel, and maybe I'll just play some of the video in the background, and we can just monitor. So I'm hoping that we'll get started at 10 o'clock, Chris, if that's all right with you, on Thursday.
10 o'clock on Thursday.
10 o'clock. If that doesn't work out and it's too congested, maybe later on in the evening if you have time. It would probably be after 5, maybe 6 or 7. I leave on Friday morning, so we'd have to figure something out. So maybe after this we can talk a little bit. But cross fingers that we'll actually be able to pull this off on 10. So as Chris mentioned, he's going to host it from his stronghold there, and then I'll be the man on the street. And I hope it'll all work out.
Either way, you gents have a blast. CES, I have a feeling, is going to have some good ones this year. Look forward to seeing the Bitcoin section, of course. And I've heard the 3D printing section is, the LA Times reported that the 3D printing section is like 3 times bigger or something like that. It
is, so
it'll
huge,
be
fun to have you on the other end as we talk about it. Okay, well that's it. So,
and thanks to our listeners, and we'll see you next time on All Things 3D.
Bye.